So vector differentiation we have started. So df by dt and d square f by dt square problem we have completed. So in that only one more problem is about finding the velocity and acceleration. Okay. So that is a particle moves along a curve whose parametric equations are x, y, z are there. So what is time? So we have to determine its velocity and acceleration at t. Okay, for some questions they will give t value. That is t value maybe 0, 1, 2 like that, any values they will give, or else they will ask only for the finding the time t. Okay. So one question is a particle moves along the curve whose parametric equations are so the equations are x is equals to e to the power of minus t, y is equals to 2 cos dt, and z is equals to 2 sin dt. Okay, where t is the time. Where t is time. So determine its velocity and acceleration. Okay, this is the question. So this is in your model examination questions you have. So we have to find velocity and also acceleration for the given parametric equations. So with parametric equations, they are given as x, y, and z. Okay, that is x of t, y of t, and z of t values it has given. So you have to write it in the form of a position vector, that is r is equals to xi plus yj plus zk. Okay, so let r is equals to xi plus yj plus zk. Okay, this is the position vector of r with the coordinate axis x, y, z. Okay, so here substitute x, y, z values of given one. So r vector r is equals to, what is our x value? E to the power of minus t I bar plus 2 cos 3t j bar plus 2 sin 3t k bar. Okay, this is our position vector r. Now we need to find the velocity and also acceleration. So velocity v is equals to dr by dt. Okay, so if you differentiate the given r, then you will get the velocity value. So dr by dt means e to the power of minus t differentiation is minus e to the power of minus t I bar, and cos 3t differentiation is minus sin 3t. Okay, and again 3 you will get multiplication. That 3 if you multiply here, you will get it as 6. That is minus, you will get minus 6 sin 3tj. Here sin 3t also it will become cos 3t, and 3 2s are, it is 6. So 6 cos 3t k bar. Okay. Now we have to find here for at the time where time t means you will have the t values like that only. So velocity value is this one. Next, if you will go to the acceleration. So acceleration means we will represent it with small a. Acceleration a is equals to dv by dt. Okay. dv by dt means this is the v value, velocity value. If you do the differentiation of that one, then it is called as the acceleration. So it is equals to differentiation of this one means e to the power of minus t differentiation is Again, minus e to the power of minus et. So minus of minus means it will become plus I minus, here 6 3s are 18. Sine will become cos 3t j, and here cos will become sine. So minus, you will get minus 6 3s are 18 sine 3t k bar. So this is the value of the velocity and acceleration when the parametric equations are given. Okay. So first you have to take this r value. R is equal to the position vector of this 3. So if you substitute here, you will get the r. If you do the first differentiation, you will get the velocity. If you do one more differentiation, you will get the acceleration. Okay. So these are some problems regarding the differentiation. Next, partial differentiation is there. Partial differentiation means, so dou f by dou x. Okay, next one is about the, we have seen the differentiation and also partial differentiation. In partial differentiation, if vector f is equals to cos xy into I bar plus 3xy minus j bar minus 3x plus 2y into k bar. This is the given vector. Okay. So vector f is equals to these values. Then find, okay. So here different forms of the differential partial differentiation is given. First one is dou f by dou x. Okay. So we call even it as a, like this also we write first order partial differentiation means. So it is equals to, and we need to do the partial differentiation. Okay, fx means only first order we have to do. For this one, we have to find the differentiation with respect to x. So partial differentiation means only x variables you have to do the differentiation. Other variables you have to take them as a constant. Okay. So cos xy means here cos will become minus sine xy, and xy differentiation means x value is 1. So you will get this one as minus this xy differentiation. You will get x value as differentiation is 1. So it has a quotient y. So minus y, cos will become sine. Okay. And here 3xy. So 3xy means x differentiation is 1. So you will get it as 3y minus 2x square means x square differentiation is 2x. So 2 to the 4x into j bar minus 3x means you will get 3. And this 2y is x variable is not there. So you will get only 3x. So that is 3k bar. That is vector. Okay. So this is the first order partial differentiation. Next, with respect to dou f by dou y. Okay. So this is f with respect to y is equals to, that means we have to do partial differentiation with respect to y here. So cos xy means it will become, y differentiation is 1. So x will be there here. So minus x sin xy vector plus here 3xy means y differentiation is 1. So you will get 3x and 2x square. Y differentiation is not there. So only plus 3x into j vector. And here 3x is y variable is not there, so this is 0. And 2y differentiation means it is minus 2. So minus 2. So this is the differentiation, partial differentiation with respect to y variable. Next, we have second order. So second order is dou square f by dou x square. Okay, even we can write it as fxx. That means for this one, you have to do the partial differentiation one more time. So this sign will become cos, and again x differentiation is 1. So y will be there. No, y into y means it will become y square. So minus y square, sign differentiation is cos xy vector I, plus here x variable is not there. So this is 0 and this is minus 4. So minus 4j. And here no variable, either x is not there or y is not there. So it will be constant. So that value is 0. Okay. So next fourth one is dou square f by dou y square. It is equals to f y by. So for this one, we have to do the partial differentiation. So the sign will become cos, and here it will become x square. So minus x square cos xy into y, and here x is there. That means y variable is not there. So, and even here also y variable is not there. So these two values will become 0. So only this is the value of dou square f by dou y square. Okay. So next one more is, that is dou square f by dou x into dou y. Fourth one is this one. So fifth one is dou square f by dou x into dou y. Okay. So it is equals to, we can write this one as dou by dou x into dou f by dou y. Okay. So if you multiply that, we will get it as same one. Now it is equals to dou by dou x of, what is dou f by dou y value? So it is minus x sin xy minus 2k. Okay. So this is the value of dou f by dou y. And now you have to do the partial differentiation with respect to x. So if you do the partial differentiation with respect to x means, wherever x variable is there, you do the differentiation. So it is equals to minus x, here sign will become cos, and here this x is there, no, x variable will become 1 and y will be there. So that means minus xy cos xy I, and this 3x will become 3j, and here no variable, so it will be 0. So this is the answer for partial differentiation with respect to x and y. Okay. So like this, you have to do the partial differentiation for the given any vector function. So like he may ask given these all forms, that is the first order, these two are, and these two are the second order, and this is the combination of x variable and y variable. Okay. So these are the important topics in second unit, and one more is you have the problem on unit tangent vector at any point of the curve or vector r is given. So you have to find the unit tangent vector of the curve. So dou square f by dou x dou y value is this one. So next last problem in the second unit. Find the unit tangent at any point of the curve r equals to 2 log t plus 4tj plus 2t square plus 1 into vector. Okay, this is the given problem. So we have to find the unit tangent vector of the given curve. So the unit tangent vector to the curve at any point is the unit tangent vector to the curve at any point is. So we need to find first dr by dt. So dr by dt means that is the first order differentiation of the given one. So 2 is constant, log t differentiation is 1 by t. So 2 into 1 by t and 4t means you will get 4 and 2t square means you will get 4t and constant differentiation is 0 for 4t k. So this is the dr by dt. So for unit tangent vector, the formula is dr by dt by modulus of dr by dt. Okay. So now we'll find the modulus of this one, that is dr by dt mod. So modulus means what? The quotient of x, y and z, whatever are there in place of x, y, z values, you have to do the square of them. So that is root of, this is 2 by 2, 2 by t whole square plus 4 whole square plus 4t whole square. So it is root of, this is 4 by t square and this is 16 plus this is 16t square. Okay. So the required unit tangent is root of these values. So unit tangent vector is, the required unit tangent is so dr by dt by modulus of dr by dt. Okay. So it is equals to, what is dr by dt value? 2 by t I plus 4j plus 4tk by under root of 4 by t square plus 16 plus 16t square. Okay. So this is the unit tangent vector of any given curve at any point. So like this, we have to find the solution for this problem. So by this, we are completing the unit 2 of block 1. So next we'll go to the unit 3 in block 1. So unit 3 is about gradient and divergence and also curl of operators and their algebra. So how we'll use gradient of a vector or divergence of a vector or curl of a vector. These three are called as operators. So how they are used in solving the problems. Okay, that is about the unit 3, and this unit is the important one. So you may get one 10 marks question and one 5 marks question from the unit 3. So you have the definitions of what is gradient of a vector and what is a divergence of a vector and what is a curl of a vector, and how they are defined. So unit 3 is, you have the definitions of all the different operators. So first one is the gradient of the vector. So you have the definition. Sometimes they will ask the definition, or else how it is denoted and how it is defined. It will be asked for the objective type of questions. So first one is gradient. So gradient we will use for a scalar function. Okay, gradient of a scalar point function. Gradient of a scalar point function. Okay, so the gradient of pi, we denote it as a here whatever the scalar is there, that scalar point function is denoted as pi. Okay, and we'll denote gradient of a scalar point function as grade into that pi. Okay, or del into pi. Okay, the gradient of pi denoted by we write like this, or del into pi. Okay, so here now no dot product or no cross product, just del into multiplication of pi, where pi is here scalar point function. Okay, and defined as that is del pi is equals to I into dou by dou x into phi plus j into dou pi by dou y plus k into dou pi by dou z. Okay. So this is the definition of gradient of a scalar function. Scalar point function del into pi. This is called as del, or it is called as nabla. Nabla or del. So even you can write this as, that is, you can separate dou by dou x plus j into dou by dou y plus k into dou by dou z into pi. Okay, like this you can, that is any given scalar point function, you have to multiply with the del. Del value is I dou by dou x plus j dou by dou y plus k dou by dou z. Okay. So del is, this one is a vector differential operator. So into pi, only this del is equals to this one. That is I dou by dou x plus j dou by dou y is a vector differential operator. We call it as del or nabla. Okay. So here pi is the scalar point function. And pi is these 2 points. Remember, pi is a scalar point function. Scalar point function. Okay. So this definition is important of the gradient of a scalar point function, and gradient, how we represent it and how it is defined. These 2 concepts are important. And for each and every operator, you have the properties are there. That properties you will get for the objective type of questions. So here the properties are properties of a gradient of a function. Properties of gradient. So first one is a scalar point function phi of x comma y z, if it is constant. So a scalar point function phi of x comma y comma z is a constant. So this will be a constant function if, this is the symbol for if and only if. Okay. If and only if del f equals to del pi equals to 0. Whenever del pi equals to 0, it will be a scalar point function, will be a constant function. Okay. This is the first one. Next, and second one is if pi is given for x comma y comma z, and one more function is given, scalar function, that is psi of x comma y comma z. Okay, these scalar point functions. So then del into pi plus psi is equals to del into pi plus del into psi. Okay. And the third and fourth properties are, third one is, that is del into any constant function into psi is equals to, you take out that constant function into del into psi. Okay. So these, and one more is, that is a into pi plus b into psi is there. So that property is also there. Next, we'll see one problem on how to find the gradient of a vector. That is del value will be del into pi value will be given in the problem. If you write that, it's enough. So these properties you will get for the objective type of questions. Okay. First one is find del into x cube plus y cube plus z cube minus 3yz. Okay, x cube plus y cube plus z cube minus 3xyz. So this is a scalar function. Here I, j, k are not there. Okay. So we have to find the del of this one. So what is the del here? Del the value is I dou by dou x plus j dou by dou y plus dou by dou z. Okay. Into this function, that is x cube plus y cube plus z cube minus 3xyz. So here you have to multiply this I dou by dou x with that function, each and every one. So you will get it as I dou by dou x of x cube plus y cube plus z cube minus xyz plus j into x cube plus y cube plus z cube minus xyz. Okay. And with respect to k into dou by dou z also, you have to multiply that one. So plus k into dou by dou z into x cube plus y cube plus z cube minus xy z. Okay. Now you have to do the partial differentiation with respect to x, with respect to y, and with respect to z. So I into, first you keep I like this only. Then the partial differentiation with respect to x means x cube differentiation is 3x square. And here y cube is there, z cube is there. With respect to x we are doing, so these two will become 0. And here x differentiation is 1, so minus yz. Okay. Next plus j vector into dou by dou y. Y cube is there, so it will be 3y square minus, there x will become 1, so x into z. Okay. And next plus k into here z cube. Z cube means 3z square minus xy. Okay. This is the answer of okay, here 3 is there. 3xyz. Here also 3. 3. Okay, so 3 it will be minus 3yz minus 3 minus 3xy. Okay, if you will take out 3 common, it will be 3x square minus yz into I plus, so for whole you take out 3 common, it will be just y square minus xz into j plus z square minus xy into k. Okay. Like this, we have to find the answer whenever he's asking to find the gradient of the scalar function. Okay. So gradient, if like this, you have to find. And one more point will also be given in the question. So find the gradient f when f of x comma y comma z equals to some function is given at the point. So at one point he will ask, that point is 1 comma minus 1 comma 2. So gradient of f equals to find grade f when f of x comma y comma z is equals to x cube minus y cube plus x z square. Okay, plus x z square at the point 1 comma minus 1 comma 2. Okay, this is the given point we have. So we need to find the gradient of the vector. So point is 1 comma minus 1 comma 2. And here in the solution, so grad pi is equals to f is, so our function is f is equals to del f. Okay. So here gradient pi f is equals to del f. So f is our function is x cube minus y cube plus x z square. So what is del? Del value is I dou by dou x plus j dou by dou y plus k dou by dou z into our function. Our function is x cube minus y cube plus x z square. Okay. Now if you multiply this one, I dou by dou x of x cube minus y cube plus x into z square plus j into dou by dou y of x cube minus y cube plus x z square plus k into dou z of x cube minus y cube plus x into z square. Okay. So now this one with respect to x means it will become I into x cube is 3x square. Here 1 means plus z square plus j into minus 3y square. And there y is not there. So it is only minus 3y square. Plus k. Here z is there. Z square means it is 2z. That is 2x z. Okay. So this is the difference, partial differentiation of that one. Now we have to find this grad f at the point 1 comma minus 1 comma 2. Okay. Grad f at 1 comma minus 1 comma 2 is equals to, that means in place of x, y, z, you have to substitute this point 1 minus 1, 2. This is x value, this is y value, and this is z value. So I into 3, x value is here 1, 3 into 1, plus here z square. Z square means 2 is there, 2 whole square. Okay. Or else I will write it above. It is equals to I into 3 into 1 plus 2 square plus j into minus 3y square. Okay, you can take the minus here. 3 into y square. 3 into y square means minus 1 square. So minus 1 square means it will be 1 only. So minus 3j you will get. Next plus k into 2 into x into z. 2 x value is 1, z value is 2. So it is equals to 3 plus 2 square means 4. 3 plus 4 means 7. 7i minus 3j. This is 2 to the 4k. Okay. This is the answer of the grad pi when one point is given. Next we have the concept of directional derivative is there. One of the concept in this. So directional derivative of any scalar function in the direction of vector A. So for that the formula is del f, that is d pi by ds is equals to del f into vector A. In the direction of A means it will be A vector you will have. Directional derivative of a scalar point function. Point function. So for this, the formula is that d pi by ds is equals to del pi into A. Okay, vector A. So this is the formula. If you remember this formula, you can solve the problem. So on this, we have one problem, that is find the directional derivative of one of the scalar function along the vector j minus k at the point 1 comma minus 1 comma 2. Okay, this is the question. So you have seen the directional derivative formula, that is del pi into A, that is a unit vector A. So we see the problem on this. Find the directional derivative of directional derivative of x square plus y square plus z square along the vector that is j minus k at the point 1 comma minus 1 comma 2. Okay. So here the given vector function is, that is, let pi of x comma y comma z is equals to x square plus y square plus z square. So what the directional derivative means? Del into pi into vector A. So then del pi is equals to I dou by dou x plus j dou by dou y plus k dou by dou z into x square plus y square plus z square. That is I dou by dou x into x square plus y square plus z square plus j into dou by dou y x square plus y square plus z square plus k into dou by dou z into x square plus y square plus z square. Okay. So this, if you do the partial differentiation, you will get 2xi plus 2yj plus 2zk. Okay. Here x square differentiation, here y square differentiation, here z square differentiation. Now given direction along the curve, it is given. No, the curve is so given direction is vector A is equals to j minus k. Okay. So now substitute in the formula. That is unit vector in direction of A is equals to unit vector. Okay, this is the unit vector here. It is the unit vector in the direction of vector A is equals to vector A by modulus of vector A. Okay. So this is the formula we have. So vector A is j minus k by its square, that is 1 square plus minus 1 square. So you get j minus k by root 2. Okay. This is the unit vector. So now directional derivative of pi in direction of A is, it is directional derivative. I am writing in shortcut, that is dd. Directional derivative of pi in the direction of A, that is unit vector A is equals to del into pi into vector A. Okay. So this is what we got, del pi value. Del pi value is this one, 2x into this. So 2x into plus 2y into j plus 2z into k. And the unit vector value is this one, that is j minus k by root. Okay. So now you find the dot product of these two. So when you find the dot product of this one, here x into I, vector I is not there here. So this value is 0. This into this one, that is 2y plus 2z by root 2. That it is equals to 2y plus 2z by root 2. So along the point, it is given at the point 1 comma minus 1 comma 2, it is equals to, so this is y value and this is z value. So we will get it as minus 2 into 1, or it's 2 into minus 1 we can write. Plus 2 into 2 by root 2. So it is minus 2 plus 2 2s are 4 by root 2. So minus 2 plus 2 means it is 2 by root 2. Here minus j is there, no? So we'll get minus 2z. So minus 2z means this is minus 4. So minus 2 minus 4. So it is minus 6 by root 2. So 6 you can write it as minus 3 into 2 by root 2. And you can write the 2 as root 2 into root 2. By root 2. So root 2 will get cancelled. So the answer is 3 into. So this is the solution for finding the directional derivative. So this you will get the question for the examination in the 5 marks question, or combination of the 2 questions you will get for the 10 marks question. See the questions in the textbook, how it is framed for 5 marks question and how it is framed for the 10 marks question. So this is the concept of the gradient of a scalar point function. Next, second one is about the divergence of a vector. Divergence of a vector point function. A divergence of a vector function. It is denoted as div. So for the vector function, f is equals to f1i plus f2j plus f3k. So this is the vector we have. So f1i plus f2j plus f3k is any vector. So divergence of f is denoted by then divergence of f is denoted by div f, or we call it as del dot f. Okay, here dot product will be there and defined as div f equals to and defined as equals to del dot f. Okay. So del means what? Del means I dou by dou x plus j dou by dou y plus k into dou by dou z into f. So here f is equals to f. Okay, here this f value is equals to whatever above it is there. So f1i, if you write in place of f, the value you will get it as I into dou f1 by dou x plus j dou f2 by dou y plus k dou f3 by dou z. And this is the definition of this one. Remember that. So gradient means dot product will be not there, and divergence means dot product will be there, and it will be a vector function. So whatever the answer you will get, that will be any scalar value you will get for the divergence of a vector. And one important one is if div f value is equals to 0, then that vector f is said to be solenoidal. So this question also you will get for the objective type of question. And properties are there. So see the properties from the textbook. So one important property is, that is note if you will see del dot f is not equals to f dot del. Okay, this is one. And next one is if a vector function f is said to be solenoidal if del or div f you can write. Div f equals to 0. So this is the important one. Next one problem on this. If R is given like this, vector R is equals to xi plus yj plus zk. Then find divar. So divar means it is div R is equals to del dot R. So what is that? Dou by dou x plus j dou by dou y plus k dou by dou z into R. R is xi plus yj plus zk. So what you'll get the answer? That is this into this multiplication. X differentiation is 1, y differentiation is 1, z differentiation is 1. So we'll get the scalar value when you do the differentiation, divergence of any vector. Okay, like this you have to solve the problems. To see the example problems on your test book and solve the problems. So next week we'll see the other units. So this is the divergence of the vector. Gradient will be for the scalar point function and divergence will be for the vector point function. Next, another one is third one, that is a curl of a vector. That is also for the vector point function only. We'll write curl means you will have curl cross. That is, you will have the cross product will be there. Divergence means you will have the dot product. Next class, we'll see the other topics of the, so almost we'll complete the block 1 and next we'll go to the block 2 in next class.